one end of a spring is attached to a solid wall while the other end just reaches to the edge of a horizontal frictionless tabletop, which is a distance h above the floor. A block of mass m is placed against the end of the spring and pushed towards the wall until the spring has been compressed a distance x as shown above. The block is released, follows the trajectory shown, and strikes the floor a horizontal distance d from the edge of the table. Air resistance is negligible. Determine the expressions for the following quantities in terms of m, x, d, h, and g. Note that these symbols do not include the spring constant. A. The time elapsed from the instant the block leaves the table to the instant it strikes the floor. B. The horizontal component of the velocity of the block just before it hits the floor. C. The work done on the block by the spring. D. The spring constant. Now the mass is pushing the spring. Here is the spring. It is attached to the wall, and then other end is attached to a mass. And this mass is pushed to the spring so that it compresses. Okay. Now what happens? Now the block is released. When the block is released, the spring pushes the block out. So the block falls from the table and lands on the floor. We are supposed to find out the time, how much time it takes to drop this height. This is just a simple projectile motion problem, wherein we use the formula delta y is equal to vyt plus half at square. Initial velocity along the y direction is 0, and acceleration is equal to negative g, and then delta y is equal to negative h. Therefore, using this value, plug in these values in the above equation, you will get t is equal to square root of 2h by g. Okay. Next, the horizontal component of the velocity of the block just before it hits the floor. For that one, we know v is equal to delta x by delta t, and then delta x is given as a d here, and then t just now we found out. Plug in, you get the answer. Next, the work done on the block by the spring. Work done on the block by the spring. So the spring is pushing the block. So the work is done on the block means the block has the kinetic energy. Okay, the block is moving, no, work is done on the block. So it has the it is moving with a velocity v, so it has the kinetic energy. Work done on the block by the spring. Okay, so W is equal to delta K is equal to half mv square. Instead of v, we will plug in this value. Okay, and then we get W is equal to mgd square by 4h. Next, fourth question. We have to find out the spring constant. For this, we use the law of conservation of energy. So here, initially, the spring has the elastic potential energy, and later, because it is doing the work on the block, the elastic potential energy gets converted into kinetic energy. Okay, that is how we have to relate. According to law of conservation of energy, the total energy of the system remains constant. So here, the elastic potential energy gets converted into kinetic energy because the work is done by the spring on the mass. Okay, so half kx square is equal to half mb square, and then k is the force constant. This we have to find out, and then x is given as x uppercase. Substituting that in this value, we know we already calculated mass, and then x substituting, we will get the k value as this one. This is the answer for this question. Hope this helps. Thank you. Bye bye.